All right, welcome back to Mr. P Helps with Algebra 2. This is Unit 1, Topic 3, SLT number 25. So in this case, we are doing logarithmic functions. We are graphing them just like we did in the prior video, but we're doing it with transformations. This is a logarithmic function, so this has an asymptote of x equals -3. So right here at -3 is the line at which it'll never reach. It has a domain, which is everything up to the right of -3 or greater than it. It goes up and down infinitely. It's increasing the entire time, so when x is greater than -3, and it's never decreasing. This one has an asymptote of x equals 0. Its domain is everything greater than 0, and its range is all real numbers because it's going up and down infinitely. It's increasing never, and it's decreasing when x is greater than 0 during the entire domain. So during the entire time, it's going down. All right, so we're going to get into transformations, going up, down, left, and right. The nice thing about transformations is that they work the same for every type of function that you've seen up to this point. And it's going to continue to do the exact same. So h, just like in quadratics, which is probably when the first time you ever did this, or maybe even linears, first time you ever did this, so h always moves the function left and right, and k always moves the function up and down. And then a does two things. A determines the stretch factor. So in this case, it's how much it's stretched. It's how fast it goes up or how much it increases. And it also determines if it's positive or negative, whether or not it's going to be flipped or reflected over the x or y axis. B, this number in front of the x will determine if it's reflected over the y-axis, whereas a will determine if it's reflected over the x-axis. What I mean by that is, what if it's 2x minus 1 on the inside? So that 2 is greater than 1, so therefore that's going to give you a horizontal shrink. It's going to make it compress together. Whereas we're talking about vertical stretch, that means going like this, and vertical shrink would be going like this. All right, describe the graph and how it can be transformed to make it g of x. So this is a right 3. All you got to do is look at the notes, and this is up 2. Right 3, up 2. So this is left 1, down 5. So remember, this is h, this is k. That's h, that's k. So this 2 right here on the outside, so that's kind of like the a. So anytime it's greater than 1, that means it's going to be a vertical stretch. That means it's going to stretch it out a little bit. It's going to make it go up faster, I guess. It's going to go, the next point's going to be up 2. Same thing goes for this one. So this is not left or right anything. It's just up 4. So it's been translated up 4. And then the -8 means it's reflected over the x-axis, and it's also greater than 1. So therefore it's going to be stretched. It's going to make it go up much, much faster. It's by 8. The next point's going to be 8 above. So it's going to go up real fast. So this 2 is like a b. So that means it's going to be shrunk. It's going to actually compress it. It's going to do the opposite of what you would think it would do, which makes sense because whatever's on the inside the parentheses always does the opposite of what you would think it does. So this is actually going to make it shrink. And the -3 on the outside is going to make it translate 3 down. Okay, so what about if it's exponential? So this is what it'll look like if it's exponential. So I believe these are all linear functions. So now we have our exponential functions. So this is our rate, this is our y-intercept, and this, as we know, is our asymptotes. So this is going to translate it up 4. There is no number right here that's going to make it move left or right, so it's not moving left or right anything. This is going to move right 1 and down 3, and then keep in mind that this is your number on the outside, so that's actually going to make it, that's acting as if it's an A. So the fact that it's negative, you can see it's -4, is going to reflect it over the x-axis. If this number had been negative, it would reflect it over the y-axis. So reflect over the y-axis and translate down 2. This is going to be reflected over the x-axis, and this is going to move left 8. All right, so what about if it's logarithmic function? So the inside moves it left or right, the outside moves it up or down. So this is going to move 2 left, this one's going to move 1 right, 7 up. This one's going to move 5 up with a reflection over the x-axis. This is going to be a, so once again, we go back here, so that makes it 4, so it's going to be a stretch. So that's going to stretch it vertically, and this is going to move it right 3 and up 1. Okay, so actually getting to the graphing. So the way to graph this without a graphing calculator, because remember, you can't put this in a graphing calculator 10 is the only thing that it can do in the calculator. So there's got to be another way of doing that. So what you do is, well, we can do this by hand. So first find out what is the asymptote. 3 to the 0th power. So 3 to the what power is 0? That's not possible. So that's the asymptote. So you always want to do whatever it takes to make the inside 0 is always going to be your asymptote. So in this case, your asymptote is going to be 1 because 1 minus 1 is 0. So whatever it takes the inside of parentheses to be 0 is the asymptote. And then just count up from there. So 1. So 3 to the what power is 1, and that would be 0. What would it take to make it 3? So I'm going to go to 3 because it's base 3. So 3 to the what power is 3, that would be 1. So there's enough points for me to do. So x equals 0 is our asymptote. 1, 0 is our 1 point away, and then our base is 3, 1. So notice what's happened here. The next point, so it's always the next point's going to be 1 away from the asymptotes, and the base will always be the distance to the next point after that. So the next highest point will be the base away. So if this is 3 away here. So had it been base 5, this point would have been right here. All right, so then same transformations here. So what if I want to make this 1. So the next number would be 2. So 2 minus 1 is 1. 3 to the what power is 1, and that'd be 0. 0 plus 2 is 2. And then 3 minus 1 is 2. Oh, I'm sorry, I want to make it 3. So I want to make this 4. 4 minus 1 is 3. 3 to the what power is 3. That'd be 1. 1 plus 2 is 3. All right, I'm going to graph this one in a different color. So it's got an asymptote of x equals 1. And it's got 2, 2. And then it's got 4, 3 right here. And what you should be noticing is that this graph and this graph look pretty much the exact same thing. The only difference is this one's been slid 1 right. You can see that in the asymptote. And it's also been translated 2 up. So this point went up 2. So this point got slid 1 right and 2 up. This point got slid 1 right and 2 up. That's what's been done to all the points. Great. Homework. Let's get straight to it. So this is log base 2 of x plus 4 equals negative 1, minus 1. Sorry, not equals. All right, so remember, x equals, you always have the asymptote of whatever it takes to make this 0. So in this case, this is just x. So 0 is what makes x 0. The next one I'm going to use is 1 because anything to the 0th power is 1. And then I'm going to use the base as the next number. So to the first power is 1. Okay, so there is... Okay, I messed that up. So 1, 0, and 2, 1. And there is the parent function. But then we want to change it up over here. So what does it take to make this 0? That's negative 4. So the next number would be negative 3. Negative 3 plus 4 is 1. 2 to the 0th power is 1. So that's 0. 0 minus 1 is negative 1. Negative 3, negative 1. So what do we have here? Okay, so this has been moved left 4. So it's got a vertical asymptote of negative 4, negative 3, negative 1. And the next number, let's see, if I use negative 4 is the wrong way. So it's got 2 as the base, so let's use negative 2. Negative 2 plus 4 is 2. 2 to the 0th power is, I'm sorry, 2 to the first power is 2. So that's 1 minus the 1 at the end is 0. Negative 2, 0. All right. Without a calculator, ladies and gentlemen, there we've done it. So look at the transformation. What has happened to this point? It's moved 1, 2, 3, 4 left and 1 down. 4 left, 1 down. Now, knowing those transformations, I could have gone straight to that and just graphed it from the transformation. The asymptote in this case, well, it depends on which one you're talking about, I guess, or assuming this one. So the asymptote would be x equals negative 4. Transformation has been left 4 down 1. As I said, the domain is everything right of negative 4. So that's x is greater than negative 4, and the range is up or down infinitely, which is all real numbers. Don't know why I opened that. All right, thanks again for watching. That's another successful video on how to do logarithmic function graphs with transformations. Awesome. Have a great day.